Hello and welcome back to computer programming. All right, so today we've got two main things that we're dealing with. One is we're going to learn about something called a switch statement. And two is we're going to be circling back to that calculator we set up in the function unit and adding some new features and calculations that make use of the loops that we've been covering in this unit. All right, so let's start just by going to the calculator exercise. You're going to see the zip file in there, and we're just doing what we always do. So clicking on the zip file, it's going to tell me I couldn't preview it, so I'm going to open it in a new window. All right, once I have it open in this new window, I can download it. All right, if you get any sort of message about it being dangerous, you just click on that arrow and say keep. All right. That sent it down to my computer so I can open up my Windows Explorer or my File Explorer, go to my Downloads folder. There's the zipped file. I'm going to right-click on that, choose Extract All. All right, that's going to extract the files out that I actually need. Now, I could just open it, but I like to keep things neat, so I'm going to X that out. I'm going to delete the zip file because I don't need it anymore. And I'm going to drag the unzipped version into my computer programming folder so that I have everything nice and neat with everything else. Now, let's open this up. And when we open this up, this isn't actually where you're going to be writing your code for this activity, but it's just a demo of the switch statement. All right. So here we have some code. There's a character variable x. I ask the user to type in a 1 through a 3, a plus sign, a lowercase a, an uppercase a, and then I let them type it in. And this first part should be familiar. All right, this is what we've seen before. We've seen if x equals equals. Now the 1 has single quotes around it because it's a character variable. So whenever you're using a character variable here, we're putting these single quotes around it. If this had been an integer, then you wouldn't have had those single quotes. You would have just said if x equals 1. Right? Because if it's a character, we're putting the single quotes around it. So if x equals 1, I'm printing out January, else if x equals 2, else if x equals 3, else if x equals a plus sign, else if x equals a lowercase a, else if x equals an uppercase a. And do notice that a and uppercase A can be two separate cases. That's because each one of those characters has a different what's called ASCII encoding, or a different combination of ones and zeros. So even though we kind of recognize them as the same, oh, they're both A's, the computer treats those as two distinct characters. So we can test for lowercase a, we can test for uppercase A, or we can have a default situation. So this is what we've been doing. All right, this is what we've been setting up in a lot of our programs. Anytime there are multiple options and we want to choose between one of those options. All right, the other alternative is to use what's called a switch statement. All right, and the switch statement sort of mimics this whole if, else, if setup that we have up here. All right, so we start with the word switch. All right, we have a left and a right parenthesis, and then we feed in a variable. All right, and that variable in our case is pretty much always going to have to either be an integer variable or a character variable. There are other types that will work, but for example, a string variable will not work. A float variable will not work. So for our purposes, it's mostly always going to be either like an integer or a character. And then what it does is it interprets whatever value is inside of that variable, and it tries to match it to a case. All right, so this case 1 is effectively the equivalent of if x equals 1. Case 2 is if x equals 2, if x equals 3, if x equals plus sign, if x equals lowercase a, if x equals uppercase a. And then here's our default, which is sort of like the else from up above. All right, so this is another way that we can sort of allow the user to choose between different options. All right, you've got the word case in all lowercase, and then you have the value that it's matching. All right, and again, because this is a character variable, it only holds a single value. So my case couldn't be like 1a, it's just case 1 because, again, a character variable only holds one thing. So I could have it be any case that I want, and it's going to go through and it's going to look and try to find a matching case. And when it finds that matching case, it's going to run whatever code is after this colon here. Right? Now, the break is kind of like your closing braces here. Right? It says, all right, run this code. And then when it sees the word break, it skips everything else and jumps to the bottom. All right. And then here's a separate case. It would run this code, hit the break, jump to the bottom. All right. So basically, it looks at the value, it jumps to whatever case it needs to. It executes the code underneath that case. And then when it hits a break statement, it jumps to the end. If it doesn't find a matching case, all right, it goes down here to the default. And then I don't need a break at the end of the default because it's already the last piece. Now, these two structures, the switch statement and the if else, they're gonna function the same. All right. When I run this, all right, I'll type in a plus sign. You're going to see that I get the same thing printed twice because the two things are doing the same exact thing. All right. They're producing an equivalent output. So when do you use one versus the other? And a lot of it depends on the exact situation that you're dealing with. All right. So the upside of the if else if is that if it's one of the first couple of choices, like the first, second, and third choice, it's super efficient because as soon as it finds a match, it executes the code and jumps down and skips the rest. If it's not one of the first couple, then it's kind of inefficient because I have to check this, then I have to check this, then I have to check this, then I have to check this, and I might have to go through and do 20 different checks, wasting time as I move through each of them. The switch statement takes a little more to get going. It takes a little more to set up, but then it can kind of jump to the place it needs without needing to go through and do these individual checks in the slow, deliberate manner of the if, else, if, else, if. So the general sort of rule of thumb that you can follow is that if you know the vast majority of the time, someone's going to be picking one of the first few options. All right. Imagine it's some sort of like telephone help menu. And you know that 90% of the time, somebody's going to pick option 1, 2, or 3. All right. Then this is probably actually the more efficient way to go. All right. Because the few times that they're going to pick one of these low ones aren't that big of a deal because 90% of the time they're going to pick one of the first few. And when they pick one of the first few, this is a super quick and efficient way of setting it up. All right. If you've got 20 options and they're just as likely to pick the last option as they are the first option, like it's not like, oh, people usually pick option 1 or people usually pick option 2. They're just as likely to pick option 7 or 10 or 15 or whatever. If the probabilities are a little more balanced, then the switch statement is usually a more efficient way of kind of setting things up and structuring your code. Now, one thing that I do want to point out, because this happens a lot when kids are writing their code and they forget, what happens if you leave out a break statement? All right, so if I delete this break statement, what actually ends up happening with the code? Like, is the break statement important? All right, so let's see what happens. I'm going to run my code. I'm going to type in the number 1, and you're going to see I get January, and then I get January, February. All right, so what's happening there? All right, well, the if else is working correctly. It's saying, all right, I typed in a 1, see out January, skip the rest. The switch statement is saying, okay, 1 corresponds to this case, so let's see out January. But then since there's no break, it just continues on and does case 2, which is the word February. And then when it hits the break statement for case 2, then it skips the rest of it. All right, so when you're setting these up, if you ever find your program like doing two things and when you only expected it to do one thing, there's a good chance that you forgot your break statement, and that's what was causing it to run both pieces all at once. All right, so again, this is just another structure that we're going to have in our toolkit, another way that we can kind of allow users to choose between multiple options. And again, general rule is if you know they're always going to be picking one of the first few, or 90% of the time they're going to be picking one of the first few, go with the if else if. If there's lots of choices and they're just as likely to pick the last one as the first one, the switch statement is probably the way that you want to go. All right, so that's sort of the new material that goes along with this lab. Now, what are you actually doing? So if I go back to the activity here, all right, there's a lab document, and you're going to be adding several features to your calculator. All right. Now, the first feature is going to be replacing the if-else statement that we set up when we first started this lab with a switch statement. All right. So, and I'm actually going to walk you through how to get that started and then let you finish it on your own. The second one is to add a function that allows users to have exponents. All right. And exponents are repeated multiplication. So basically, you're going to be setting up a loop inside of your function and then multiplying over and over and over again. All right. So if the exponent is 3, your loop needs to run 3 times and just keep multiplying the number 4. All right. So that's one function that you're going to add is an exponent function. All right. Another function that you're going to add is what's called a factorial. All right. And 6 factorial is basically 6 times 5 times 4 times 3 times 2 times 1. So again, we're going to set that up inside of a loop. All right, it's going to be very similar to the exponent. Instead of multiplying by the same number every time, we're going to multiply it by a number 1 smaller each time. All right, and again, because multiplication is commutative, you could also write this 1 times 2 times 3 times 4 times 5 times 6. Whichever way you want to write it is fine. But basically, whatever number they type in, you're multiplying all the numbers up to that point or down from that point, as the case may be. All right, so those are 2 of the functions you're going to add. The third one is what's called a permutation. All right, and you don't actually need to write a function for this one. All right, because the permutation is found just by a factorial divided by a second factorial. All right, and if you set your factorial function up correctly so that it's returning a value, all right, you should be able to do the permutation calculation just by calling your factorial function, right? And this is kind of the whole point of setting up functions using return statements, is that it allows you to sort of use them in other places and combine them and make them part of something larger. And here's an example of that. All right, so this last one, you're not actually going to need to create a new function for. You're just going to be able to calculate the answer by using the factorial function that we've already created. Right, so that's the general gist of what's happening in this lab. There is a solution, so if you want some numbers to check it off of, 4 to the third power is 64, 6 factorial is 720, and if you do a permutation of 6 and 4, you should get 360. All right, so that just gives you some test values to practice on. Now, as far as doing this, you are not working in that file we just went in. All right, when you're not working in this switch one that we just set up, you are going back to your function calculator. So if you have everything nice, neatly organized, like I've been recommending, all right, you can just go into your computer programming folder. You can click on function calculator. You can double click on your project file, and you can have both projects open in code blocks at the same time. All right, I've got this code up here that we just talked about, and then I've got this code over here. That's the function calculator that we created, a few labs ago. Now, when you have 2 projects open, notice that one of them is in bold and the other one is just regular font. All right, the bolded one is what's considered the active project. So when I go, let me close this. When I go to build and run, it's going to build and run the active project. All right. And sometimes that confuses kids because they'll be clicked over here on like the switch code and they'll go to build and run. And even though they're looking at the switch code, it brings up their calculator. Okay. So just realize that it's going to build and run whatever your active project is. Now, to change the active one, if you right click on those, you can choose activate project. So if for whatever reason the wrong one is running, you just right click and activate it, and then that'll switch over. So it doesn't matter which code you're looking at. It matters which one is the active function. All right, so to get you started on the switch statement, and then I'm going to leave you to finish the rest of it by yourself. All right, we're effectively going to take what we did and convert it over. All right, so right underneath where we ask what operation would you like to perform, and we say cin symbol, this is where we're going to set up our switch statement. All right. So you can keep going back and forth and looking at it, but you can say, all right, the first word is switch, and then I'm going to have parentheses, switch, parentheses. Now, we're not using X as our variable. We're using symbol as our variable. All right, so I've got the switch statement, symbol. Then I've got my left and my right braces that mark the whole sort of kind of unit. All right. Now, if we look back, we can say, all right, the next thing we do is a case. All right, so we could go here and we could say case. And then because it's a character variable, we're going to put that in single quotes. And that's our plus sign case. All right, so this is when they type in a plus sign. All right. Now, what happens after the case? Well, if we go back and look, all right, this is where you put the code that you want to run. All right, so I've got my case, I've got my plus sign, I've got my colon. All right, the code that I'm actually going to put underneath this is the code that was previously inside of this if else. So I'm going to copy this and I'm going to paste it underneath my case. Okay, so I've got my case, I've got my colon, and then I've got my code underneath that. So when they pick a plus sign, I'm going to ask them to type in the numbers. I'm going to run my add function. I'm going to output the result. And then when I'm done, I can say break. All right, I'm just going to tab all of this over so that it's a little neater. All right. So I've now converted this part right here into a switch statement. So you'll then continue on and say, all right, let me set up my next case, hit the colon, and then again, copy and paste this code in. You'll do a case for multiplication, copy and paste the code in. You'll do a case for division, copy and paste the code in. You'll do your default, which is I don't recognize that operation. So just a heads up here as you're working, the default should always go at the bottom. And again, the default doesn't have a break statement after it because it's the end. There's nothing it needs to break out of. When you start adding your new cases, so like when you add your exponent case, when you add your factorial case, when you add your permutation case, they need to be above the default. All right, the default should always come last. So don't suddenly go default and then put exponent, permutation, factorial underneath that. Those are all going to be above the default. So you might have like a case, exponent, and so on and so forth, but they need to go above the default. The default's the last thing that you need to do. Once you've converted the existing stuff over, addition, subtraction, multiplication, division, you can totally get rid of this if-else statement. All right, so once you've converted everything and it's working, you can totally delete that out. It's no longer necessary. All right, so at the end of this lab, you're just going to have one switch statement that goes between the different operations, addition, subtraction, multiplication, division, exponent, factorial, and permutation, and you can get rid of the if-else. Okay, so that should get you started. All right, again, the first exercise in the lab is just setting up the switch statement. All right, so number one here is all about setting up the switch statement and getting rid of the if-else that we set up the first time. Then you move on to the exponent, then you move on to the factorial, then you move on to the permutation. And again, with the permutation, you won't actually have to create a new function. You can just use the existing function, assuming you set it up correctly, to calculate the answer right up inside of the main. All right, so you can calculate it right inside the main. You don't need to create a separate function for this one, just because I want you to, I'm trying to illustrate how the return statements work and can be useful. Okay, so that is it for me. Obviously, if you have any questions, let me know. Otherwise, best of luck. All right, bye.